Factoring trinomials with no perfect squared terms. This method we're going to demonstrate here is known by two different names. One name that we call this is called the X method. And the other title by which it is called bottoms up. And X method and bottoms up are actually two separate procedure pieces of the overall process, which I'm going to demonstrate by a few problems here. Okay, the first problem we're going to look at is factor the quadratic trinomial of 6a squared plus 17a plus 5. And usually what we do for this is we're trying to factor, perhaps to solve an equation. So if we set this quadratic trinomial equal to 0, we will, by factoring, be able to figure out what the solutions are to this equation. But now we're just going to go just pure factoring. So what we're going to do first in the X method, we call the X method because we draw a big X over here, and we identify the coefficients of the quadratic trinomial by writing them down as A equals 6, B is equal to 17, and C is equal to 5. And so on the top of the X, we put the product of A and C, which would be 6 times 5, which is 30. And then the bottom of the X, we put B, and B is 17, the coefficient of the middle term. And so what we're looking for is two numbers on the left and right of the X that when multiplied together equal 30, but when added together equal 17. Notice, for example, that if we use 6 and 5, sure enough, multiply to be 30, but 6 and 5 added together are 11. So 6 and 5 are not going to work. And so it usually doesn't take very long to figure out what these numbers are. In our case, the numbers that are going to work are 15 and 2, because 15 times 2 is 30, but 15 plus 2 is 17. So now we divide each of these numbers by A. A is 6. And then we simplify. On the left side, 15 over 6 simplifies to 5 over 2. And the right side, 2 over 6, simplifies to 1 over 3. So now what we do is we write in parentheses here, x plus 5 over 2, and then x plus 1/3. And now we come to the part of the overall procedure where we use bottoms up. And the bottoms up is we take, if we have a fractional denominator on one side, we bring that 2 up over to go alongside this x on the left. And for x, for this x plus 1/3, we take this 3 and move it up over here next to the x. So our answer here is going to be 2x plus 5, and then times quantity 3x plus 1. And if we multiply these back together, we can see that we'll get 6a squared plus 17a plus 5. Except for one thing. What would that be? I happen to make this x instead of a. So let's go fix that. We'll have 2a plus 5 times quantity 3a plus 1. So this would be our answer right here. Now, I had a student today, Elizabeth, who asked if this can be done without going through as complicated procedure as the X method or bottoms-up method. I replied, yes, it can be done. And in a case like problem 2, where we have smaller numbers to deal with, it's really quite feasible. Because what are the factors of 2m squared? Well, they're going to be simply 2m and m. Okay, now next we have minus 5m plus 3. Well, for this, to get this minus or negative 5m but positive 3, we have to have a negative times a negative. And now we're really left with the factors of 3. And so we only have two possibilities. We have 1 and 3. So if we put a 1 over here on the left and 3 on the right, we can see that we have on the inside negative 1 times m is going to be negative m, and 2m times negative 3 is negative 6m. Well, these are going to add up to negative 7m, which is not going to work because we need negative 5m. The only thing we can possibly do differently is put the order of the 1 and 3 and just exchange them. So I'm going to back up and erase just by doing this and put 3 and 1 here. And now if we have on the inside negative 3m, on the outside we have 2m times negative 1, which is negative 2m, and these together add up to negative 5m. So this is going to be an answer here. Quantity 2m minus 3 times quantity m minus 1. So next I'm going to go back and use the x method, and one that has a little more level of complication. So we have 6a squared minus 19a plus 10. I invite the viewer to pause the video and then play ahead afterwards to see if you got it right after having worked it out. Okay, so the first thing I'm going to do is write the x out here. I'll put a, c, and b. Well, a is 6, b is negative 19, and c is 10. So on the top here we have 6 times 10, which is 60. At the bottom we have negative 19. And so what we're looking for now are two numbers which, when added together, equal negative 19, but multiplied together equal 60. So we should be able to figure out that we need a negative number on both sides. So we have to have negative times a negative. Well, you can try 20 times 3, 15 times 4, 30 times 2. Well, what we're going to see, to get 19, we're going to have 15 and 4. And so that would be it, because if we add negative 15 and negative 4 together, we get negative 19, but multiply negative 15 and negative 4 together, we get 60. And we divide by a on each side, and a is 6. So on the right side, we get negative, simplifies negative 2/3. The left side, we simplify to negative 5/2. And so now we write this out as a minus 5/2, and then a minus 2/3. And then we bottoms up the 2 on the left linear binomial, and then we bottoms up the 3. So what we get here, and will be our answer here, is quantity 2a minus 5 times quantity 3a minus 2. And we should be able to see that if we multiply these together, we get negative 15a here. And then 2a times negative 2 is going to be negative 4a, which when added together equal negative 15a, negative 19a, excuse me. So this is going to be our answer here. Okay, we have some of these with x and y together. I want to do one of those just to show that a little more complexity can be handled. Let's see if I can. I want one with like different variables involved here. So here we have 3c squared plus 13cd minus 30d squared. So we have a is equal to 3, b is equal to 13, and c is equal to negative 30. So we use the x method again. AC, 3 times negative 30, which is negative 90. Down below b, which is 13. So we're looking for two numbers which when added together equal 13, but when multiplied together equal negative 90. So we have to have a negative times a positive. So what are your possible factors of 90? And you can just kind of write these out. Factors of 90 would be like 1 and 90, 2 and 45, 5 and 18. Is that right? 5 times 18. Yeah, that's going to be right. And I think this is actually going to be it, because if we take 18 and negative 5 and add 18 and negative 5 together, we get 13. But multiply 18 and negative 5, we get negative 90. So the next step is we divide by a, which is 3. So on the left we get 18 divided by 3, which is 6. On the right side we get just negative 5/3. We'll just leave that alone. So we're going to have a c, we're using c, plus 6d. Okay, see where the other letter comes in here? 6d times, we have c minus 5/3 d. And we bottoms up this 3 over here. So we should get c, quantity c, plus 6d times quantity 3c minus 5d. And then we're going to do a quick check to see if these multiplied together will work out right. In the middle, we get 6d times 3c, which is going to be 18cd. And then we have c times negative 5d, which is going to be negative 5cd. And these add up to 13 here. So this is it. So these are all the exercises I'm going to work in this video lesson. There are many other problems in this exercise set. I hope this has been helpful to you. The bottoms up method, or alternatively called the X method, is a good way of solving these, especially for more complex types of factoring of quadratic trinomials. I hope this has been helpful to you. Good luck, and thanks for viewing.